In this video, we'll go over the homework that follows the lecture on arc lengths in polar coordinates. And as always, I hope that you watched the lecture. And let's go ahead and jump right into the homework. And the first question is asking us to, for a given polar curve, to find the arc length for a certain range of values of theta. And the formula that we're going to use is a variation of this formula that we learned earlier. However, for polar coordinate, or rather for polar curves, this formula looks like this. It's going to be the integral from alpha to beta. And again, the setup is like this. We have some polar curve, and alpha is the initial angle, beta is the terminal angle, and here's what we're going to do. We're going to do the square root of r squared plus r prime squared d theta. So this is the formula that we're going to use, and in order for us to use this formula, we have to identify alpha and beta. It seems like alpha is 0, beta is pi, and we're going to find r prime. So r prime is just 4e to the power 4 theta. So the integral representing the arc length is the integral from 0 to pi, square root of r squared plus derivative of r squared d theta. This is the integral, and we're not supposed to find it, so let's just go ahead and enter this setup. So we can, I guess, simplify it just a little bit. We have integral from 0 to pi, square root e to the power 8 theta plus 16 e to the power 8 theta d theta. So altogether we just have 17 e to the power 8 theta inside of the radical. So I'm going to enter that. 17 e to the power 8 theta. Shift Alt TH. Next time I try to enter it. Oh, maybe. Let me try. Shift Alt TH. Oh wow, it worked. That's pretty cool. Alright, well, that's the integral. Alright, great setup. Let's do another problem. This time we have to find it. So once again, we have a polar curve. We have the domain. And now we're going to use this formula to set up the integral. So the integral for the arc length will be the integral from 0 to pi over 2 square root of r squared plus r prime squared d theta. And let's simplify it. So we have e to the power 12 theta plus 36 e to the power 12 theta d theta. So we have square root of 37 e to the power 12 theta. We can simplify this. So it becomes square root of 37 times square root of e to the power 12 theta. Now square root of 37 is just a constant, and e to the power 12 theta inside of the square root becomes e to the power 6 theta. And this is just a simple integral that we can do with the substitution t equals 6 theta. I'll just write the answer here. We're going to have 1/6 e to the power 6 theta from 0 to pi over 2. Plugging everything in, and we get e to the power 3 pi minus e to the power 0, which is 1. So this is the exact answer. So we have square root trying to figure out what do I need to enter here. As a shortcut, but anyway, square root of 37 over 6 e to the power 3 pi minus 1. Oh. Oh, I learned the shortcut. Okay, so that's the answer. This was problem number 2. Let's take a look at number 3. Here we have to do the approximation, so we may not actually have to do it by hand. We can just use technology at some point. Let's keep that in mind, but we still need to know how to set up this integral. So this is the formula that we're going to use. And I'm just going to use it. R squared is negative 1 over theta squared plus r prime squared. R prime is the derivative of negative 1 over theta with respect to theta, so it's going to be negative 1, which will become positive, and here we'll have theta squared d theta. Let me simplify it just a bit. So we have 1 over theta squared plus 1 over theta to the power 4, and finding the common denominator and simplifying. And I do believe we can do this one by hand. I'm not going to try, but it looks like just a trigonometric substitution. So let's go ahead and plug it into some sort of technology. So we have integral from pi. That was not my intention. Oh, sorry, this is Desmos. I don't need to use any shortcuts. So we put 3 pi over 4 to pi, and then we have a fraction inside. We have square root of theta squared plus 1 over theta squared d theta. And the answer is approximately 0.30674. So 0.31. Another similar problem. This time we have a circle or something like this. And to set up the integral for the arc length, we're going to use this formula. And let's go for it. R squared is -10 cosine theta minus 10 squared plus derivative of r squared d theta, and derivative of r will be 10 sine theta. Now we're going to simplify this. So we have 100 cosine squared theta plus what is it, 200 cosine theta plus 100 plus 100 sine squared theta d theta. Continue. So 100 cosine squared theta plus 100 sine squared theta is just 100. So we have 100 plus 100, that's 200. And we can take out 200. So we have, let's write it like this. We have 200 cosine of theta plus 1. And here I see this pattern, so I'm going to divide it by 2 and multiply it by 2. So I'm going to put 400 over here. And the next step we're going to notice, so this is our new integral, we're going to notice that square root of 400 is just 20. So we're going to take that out. And what's inside of the square root we have, it's a 1 plus cosine theta over 2. This is literally, let me see. This is just cosine squared of half of theta. So that's just an identity, half angle identity. So we have cosine squared half of theta d theta, and we're going to take the square root of something squared, so it's going to be the absolute value, but because everything is positive, we can just ignore the absolute value. And now we do the substitution, and here's going to be the answer. It's going to be 2 sine of half of theta from 0 to pi over 2. So we got 40 sine of pi over 4 minus sine of 0, and we are almost there. This will be the exact answer. Before we plug it in, we don't have to risk anything. We can just check our work. So let me just type this function here. We have square root of, let's just literally type that. So the answer is 28, 28. And let's check what's 20 times square root of 2 is equal to 28, 28. So this is how we know we are correct. And this is the answer. And we finished this homework, and if you have any questions about finding the arc length in polar coordinate system, please let me know.